Hi, so today I'm going to try and tackle Hoffman Voltameter. So you spell it like that, Hoffman Voltameter. If you draw the diagram, it looks a bit like that. We'll come back to that. Let's have a look at the apparatus. There we are. That's the apparatus. Just explain it to you. What we'd like to try and do is to pass electricity through water. But you guys should know now from the bonding topic, water being covalent molecules does not conduct electricity. So that's a bit of a problem. We want to pass electricity through water and it doesn't conduct. So we use a little trick. We add some drops of sulfuric acid. The sulfuric acid provides ions, then the solution conducts electricity, and what we're hoping is that when the water goes through this mixture, when the electricity goes through this water mixture, then it's going to split the water up into the elements that make it up. So you guys should know the formula of water, H2O. And we're hoping as we do this electrolysis experiment, we're hoping that the electricity splits it into hydrogen and oxygen. Now if I show you this power pack, we've got a red lead. Now that's positive. The red lead leads to this tube here. The tube's got a tap on the end. The black lead is the negative. That's connected to the other side, and that leads to a tap there. And the great thing about these taps is, I don't know if you see the top. Let me just change that so you can see the top. The good thing about the taps is that we can put test tubes over the end and we can collect any gases that build up here where my finger is or here where my finger is. Now we need to get this apparatus running. We need to get the electricity flowing and we need to let it cook for about 20 minutes. So I'm just going to turn the electricity on. Let me bring the camera a bit closer. So, I hope you can see there we've got bubbles at both electrodes. The electrodes themselves are made of platinum. Now, they have to be made of something that doesn't react with water, doesn't react with acid, and so we use platinum because it doesn't react at all with water or at all with acid and lasts, well, I've worked here 29 years and it's still the same electrodes we use. And so they last, and because platinum is a material we use for jewellery, etc. It's not going to react, but it's going to pass electricity through the mixture, and as it does so, we get gases produced. The gases bubble through the apparatus all the way to the top there, and you can see them building up. You can see the gases there and there. Now this gas, hopefully twice as much volume-wise as that gas, but that will become apparent as the experiment goes on and on and on. Let me just show you my board. So, I'm not great at drawing diagrams, but using a ruler, you draw that kind of diagram. And if we have enough gases produced, we can try and prove that we've got hydrogen and oxygen. Hydrogen, that's labelled incorrectly, lads. 1 minute, let me get the label right for you. Right, so perhaps it's labelled better now. The wrong labelling was that I'd labelled the hydrogen side, I'd labelled that positive, and the hydrogen comes off at the negative side of this apparatus. The oxygen collects at the positive side of this apparatus. So I'd labelled the positive and negative the wrong way around, which I've sorted now, and I hope that you understand the reaction occurring is that one there, And the big numbers in front to balance the equation of how water splits up into hydrogen and oxygen is you need a big 2 and a big 2, and they're to do with quantities. So that equation shows you that you've got twice the volume of hydrogen as you're going to have oxygen. And that's precisely what I want to try and show you in due course. So while that is cooking, there's 2 little demonstrations I need to show you. And this is how we prove we have water present. Now, you know the tests for hydrogen and oxygen because we've talked about them before, but we've never got to grips with how you test for water. And you probably know to prove you've got pure water, all you do is you look at the boiling points, and the boiling point of water is 100 degrees, and the freezing point or the melting point is 0 degrees. And so if you've got pure water, the only real way of proving it's pure water is take the boiling point, take the freezing point or the melting point, 100 degrees boiling point, 0 degrees freezing point. That proves you've got pure water. You should also know that impure water will boil more than 100 and it will freeze at less than 0. So impure water gives you different results, but pure water gives you those exact results. What I want to show you now is how do we prove we've got impure water or water present. Even if we've got like a little bit of water in, say, alcohol or petrol, how could we prove the mixture had some water present? So I've got a little bottle here. The bottle is in fact full of water, but imagine that bottle was full of a mixture and you had like 10% water. What I'm about to do would work equally well if you had like 90% water or even 10% water. And the great chemical we use here is white copper sulfate. Now, a lot of you, I guess, will be familiar with blue copper sulfate. Now, blue copper sulfate is blue because it's got water inside the crystals. Any water with this chemical copper sulfate turns it blue. It's the presence of copper ions and water together that gives you the blue colour. So here I've got white copper sulfate. Now, you make white copper sulfate, I'll show you that in a minute. You can make white copper sulfate by heating this, and I'll do that. I'll show you. When we heat the blue copper sulfate, it turns to white copper sulfate. The white copper sulfate's got no water with it. Now, we use a posh word in chemistry to say no water present, and that word is anhydrous. So this chemical, the white copper sulfate, is anhydrous copper sulfate. This blue copper sulfate is hydrated copper sulfate. Hydrated meaning it's got water with it. So hydrated and anhydrous. Now watch. Actually, let me come closer to the camera. That's white copper sulfate. I'm going to squirt it with this here. Let's see if I can give you a vantage point. Squirt it there, you can see water going in, and immediately it goes blue. Blue copper sulfate. Because this here, this bottle, has got at least some water in it, otherwise we would not see the blue colour. If it was just pure petrol or pure alcohol, that would stay white. Now, because it's got blue, we know we've got some water present. And that's what I want you to learn. I want you to learn the test for any old water present is white copper sulfate. And you look for it going blue. Now, I said I would show you hydrated copper sulfate, and that's this blue copper sulfate. I'll show you what happens if we heat it. Gareth?
Yeah.
I've got your class in there.
Do you want to put 13? Sorry, I'm completely, I was like, sat there just thinking, like waiting for the bell to go for Period 4.
Right. So, I've got some blue copper sulfate now here. I hope you can see. The blue copper sulfate has got water with it. And if I heat it, then by heating it strongly, roaring flame, I can drive off the water. I hope you can see that now it's going pale blue. It was proper blue before, it's now going pale blue because the water is leaving from the crystals. The crystals weren't wet, the crystals were dry. Now what we're doing is we're driving the water that's in the crystals. We're driving it out. And you can see, probably, there's some droplets of water further up the test tube. And that's the water that's leaving. Let me just show you that. See that? The droplets of water here. There's some steam coming out the end. Maybe you can see it against my dark skin. And the blue copper sulfate is turning white. Now, let's do that more. I want you to look at the mouth of the test tube where I'm holding it. There should be some steam coming out. There. I hope you can see that. That's the water that I'm driving out. Now, as steam comes out, it gets pretty hot. And then I can't keep hold of it. If I wanted to hold it, I should use a test tube holder. But, can you see, that test tube there, the water droplets that were in the top end of the tube have fallen back down and made the top of it blue. And the bottom of it stays white, because the bottom hasn't got any water with it. So to summarise, when we're testing for any old water present, we would use white copper sulfate, and any old water present would turn that white copper sulfate, it would turn it blue. The names, the white copper sulfate is anhydrous copper sulfate, the blue copper sulfate is hydrated copper sulfate. I think in my presentation PowerPoint, I will explain that more. But let's get back to the experiment we started. I think it's cooked a little now. That Hoffman Voltameter there. Now let's get a few test tubes. Here. I'm going to collect, this is on the negative side. Negative side, that should be hydrogen. Can you see that much gas compared to that much gas? I've got double this amount of gas to that. I think this is hydrogen. Open the tap. Put my thumb over the end. I should have hydrogen in there. To prove it's hydrogen, I could get a lighted splint, test it. I hope you heard that. That squeaky pop proves that that side hydrogen gas was collected. Now, on this side, I'm a little more worried about this because have I got enough oxygen? So there, oxygen. Have I got enough oxygen to test it? Well, the test for oxygen is a glowing splint relights. I hope I've got enough. I certainly didn't have enough to fill the tube, but I think I've got enough. So here we blow this out, glowing splint, and we want to try and relight it. So now it's glowing. Let's make sure it's out first. Glowing and not lit. So that is definitely glowing. It's not lit. Watch. In the tube it relit. So that tube had oxygen gas inside it. Right. So I think that concludes the demonstration I wanted to show you. See you next time.